Use exponential functions in applications involving growth and decay. So we have two examples that we're going to run through. The first being, use the function f of x equals 266 1.001 to the, that should be x power, to approximate the nearest unit, the carbon dioxide concentration in 2000, if f of x is the carbon dioxide concentration in parts per million, and x is the number of years since 1760. So let's quickly write that function. F of x equals 266 1.001 to the x power. So what this means is, well, first, what do we want to find? Let's first identify that part. We want to use the function to approximate to the nearest unit the carbon dioxide concentration in 2000. If x is the number of years since 1750, well, how many years has passed since 1750? 250, right? So we want to know when x is 250, what is f of x? Well, f of x is 266 1.001 to the 250th power. So what this becomes, and this is when x is 250, f of 250 is equal to 266 times 1.2838650, according to the calculator. If you plug this in, wouldn't recommend doing that part by hand, but you are a brave soul if you try. Timesing these two together, we get 341.5080981. Rounding to the nearest whole number, 342 parts per million. Let's take a look at that second example. So, given the atmospheric pressure in millibars at a given altitude, x, in meters, can be approximated by the function defined by blank for values of x between 0 and 10,000. Use this function to approximate the pressure as 6,000 meters. Round to the nearest unit. X is meters, notice that. So we're going to plug 6,000 meters in for x. So let's write down that function. They gave us that the function f of x is equal to 1038 times 1.000134 to the negative x. And we know we want to plug in when x is equal to 6,000. So what this means is we have f of 6,000 is equal to 1038 1.000134 to negative 6,000. This becomes 1038 1.2838665. Excuse me. Relook at my calculator again. 0.4475593, and it continues on. So then if I times those two things together, I have 464.5666. What that means is approximately 465 millibars is what we get if we round. So exponential functions are useful, actually very useful, in modeling real-life data. And we're able to then approximate things we want to know about using them.